Hi. So in the last video, we were discussing about arrays. So we have seen what is this array and why we need array. So just to recall that to store multiple values in a single variable, we create a array. Okay. So I had discussed in the last video that how to access the elements of the array, how you did, find that, how to initialize it, how to loop through the elements of the array, how to access or take input in the array, how to print on the array, print on the screen the elements of array. So let's see today multi-dimensional array. So one we have seen the last, that was single dimensional array or one dimensional array, that is this kind of. See, this is the array which is denoted as one dimensional array. So index was denoted by this 0, 1, 2, 3, 4, 5. Suppose it has number of 6 elements. So index start from 0 to 5. So suppose it has elements 23, 12, 3, 34, 26, 12. So elements can be repeated also here. So see, this is called one dimensional. Okay. Now we'll see multi-dimensional array, or we first start with two-dimensional array. So let's see two-dimensional array. So for one-dimensional array, we need one subscript. Like suppose array name is ARR. So we loop through array I using this subscript or index. We access the elements of the array of one dimension. But for two dimensional, we need two subscript or two index. And we can say like this, that suppose this is an array. You can think of like the structure of matrix. Suppose this has 4 rows and 5 columns. So rows number is started with 0, 1, 2, 3, and column is from 0, 1, 2, 3, 4. So for this element at 0, 0, it will be denoted by A0, 0. A is suppose the matrix name or array name. So it will be accessed by A0, 0. Then this element, the 0th row and first column will be denoted by A01. And then this one will be A02, A03, A04. This one will be A10, A11, A12, A13, A14. This one will be A20, A21, A22, A23, A24. This one will be A30, A31, A32, A33, A44. Sorry, A34. So in this way, the elements of two-dimensional array is denoted by two subscript or two index. First is for row and the another second one is the for column. Okay, so just wait. Suppose you want to declare this variable having uh, 2 rows and 3 columns. You can define this way: int ARR. Suppose the name of your array is ARR, or you can name any name. Okay, as you wish. For 2 rows and 3 columns. So first is row and second is column. You can initialize also inside this, that it has 2 rows. Suppose the first is 9, 7, 3, first row. First row has 3 columns and second row will also have 3 columns. So after this comma, 3, comma, 2 and 6. And then we are closing the main bracket. So it has 2 rows and 3 columns. And then we put semicolon. So we can write in the same line. Okay. But it is understood that it has 2 rows and each row has 3 columns. And you can access the element of this. How? Same as I have discussed here. Like suppose this one, this is 0, 0, this is 0, 1, this is 0, 2. And this is 1, 0, this is 1, 1, this is 1, 2. You can take the help of this table that it has 2 rows, 0 and 1, and column is 0, 1 and 2. 0, 1 and 2. This is 1. And first is 9, 7, 3. And the second row is 3, 2 and 6. So suppose I want to print the value of the value stored at 0, 1. We'll write printf %d, and if I write comma arr 0, 1. So what it will display? It will display the value this one. Look at it. Stored it 0, 1 is 7. So it will display 7. Okay. We can also change the value of this later on after initializing. We can change the value also later on, like suppose ARR. I want to change the value here 10. AR10. We can write directly, like suppose we want to store 19 here now. So it will be updated with this value. And now if you want to print, you can, if you want to check, you can use this statement printf and you'll see that this value has been updated. So we can loop through the values of 2D array also, as we have loop through the one-dimensional array or the single-dimensional array. But the thing is that here you need 2 counters, which one will be used for loop through row and the another for column. Let's take the same this array, this one now. But we don't initialize here. We will initialize in the loop. Like suppose I am writing int arr 2 rows and 3 columns. And now int ij 2 counters. And now I'm writing printf enter elements of array. And then scanf not scanf directly. We'll write scanf inside the loop. Right, for I equal to 0, I less than 2, I plus plus, and then we write for, we can write brace also here for j equal to 0, j less than 3. So we have 3 columns, so we write j less than 3, j plus plus. And then scanf %d ampersand arr I J, and then semicolon. And then we close both the for loop. So this for loop, this two for loop will help you to loop through rows and column. And then we have used this scanf to input the elements of the array. And similarly, we can print also with the help of this for loop. Like suppose we want to now print the elements of the array. So for I equal to 0, I less than 2, I plus plus, then we'll open this brace. Again for j equal to 0. Now j less than number of columns. So we have number of column 3, j plus plus, and then inside this we write printf %d, and the value accessed with the help of arr I j. So I is for loop and j row and j is for column, and then we close both the bracket. So this one is for taking input, this one is for printing the values in the matrix. Okay. So now if I ask you to add two matrices or subtract two matrices, that is very easy. If it is one dimensional or say two dimensional, you must know the rules for addition of matrices, and then you can do it easily. Like suppose you want to add two matrices or two array elements of two array. So let me show you. Suppose you have two array and they are of equal size 1, 2, 3, 4, and another array has also this 5, 1, 2, 3. So you want to add these two arrays and store in the third array. Store in the third array. So third array should also have be of same size, and the first element will be added to the first element of the second array. First element of the first array will be added to the first element of the second array. And similarly, second element of the first array will be added to the second element of the second array. And it will be stored in the third array or the resultant array. So what it should be? It should be 6, it should be 3, it should be 5, and it should be 7. So if I say what is the row, what is the order of this matrix? 1 row and 4 column. And what is the order of this matrix? 1 row and 4 column. What is the order of this matrix? 1 row and 4 column. Means for addition and subtraction, the order of the matrix for both the array should be same. It is one dimensional. Similarly for two dimensional also. Suppose you have this two array, 2 rows and 3 columns. So this is first array and this is suppose to a second array. And elements are 1, 5, 3. This is 2, 6, 3. This is suppose it is 3, 9, 2. This is 1, 4, and 5. So the third array in which the additions will be stored. So it will also have the same order. Now the result should be 3 plus 1 is 4, 5 plus 9 is 14, 3 plus 2 is 5, 2 plus 1 is 3, 6 plus 4 is 10, and 3 plus 5 is 8. So what is happening actually? Actually, suppose this is the first matrix M1, this is second matrix, and the third matrix in which we are storing the result. Let's say it is M3. So the element wise addition is performed. The same array positions values is added to the first matrix element and second matrix element, and the same position value it will store in the third matrix. Okay. So actually what we are doing, suppose if we are naming as M1, M2, M3. So for the two-dimensional array, how we will write? We will write M1, suppose this is M1, first one, M1ij plus M2ij, and this both of them will be stored after addition, it will be stored in M3ij. This is the whole thing we are doing for addition, and for subtraction we just have to change this plus to minus. Okay, and the rest of the things is same, means the rule is same for addition and subtraction, that order should be same for both the matrices of which we want to add and subtract. So how you will write the program for it? So first we have to take the input from the user in both the matrix M1 and M2, and then after taking the input you have to add the elements of the array. So let's write a program to add the elements of two matrices and assume 2D array. Okay, so first how we will start? Hash include stdio.h. This is what we write in every program. And then we'll start with void main. And in this, we'll write int m1, 2 rows and 3 columns. Suppose, or you can define the larger values also, and then later you can ask from the user. Okay, so for the time being, I'm just defining the m1 and 2 rows and 3 columns. M1, M2, M3 in the same line, 2 rows and 3 columns. Okay, and there's 2 counter variables I and j. After this, printf, enter the elements of first array. Elements of first array. Okay, then we will start with a loop for I equal to 0. So we know we have 2 rows and 3 columns. J equal to 0, j less than number of columns we have declared is 3, j plus plus. Otherwise, you can ask this thing number of rows and columns also from the user, and then that number of rows and columns you will iterate. Okay. So now you will ask the user using a scanner %d and ampersand m1 I j. Now close both the for loop. Now we have entered the elements of M1. Similarly, we'll enter the elements of M2. So we'll ask enter elements of second matrix or second array. I have written here array you can write matrix. Okay, so elements of second array. Sorry, again I have written array, you write matrix. It is better. After that, again start loop for I equal to 0, I less than 2, I plus plus, then bracket open for j equal to 0, j less than 3, j plus plus, and then scanf %d ampersand m2 I j, and then close this loop. So till here we have entered both elements of both the matrices. Now we'll do the addition. So for that we will again start the loop for I equal to 0, I less than 2, I plus plus, for j equal to 0, j less than 3, j plus plus, and inside this what we will write, m3 ij is equal to m1 ij plus m2 ij, and we'll close this both the loop. And after this we'll print the elements of array. The elements of resultant matrix. For this again we have to print through iterate through loop. For I equal to 0, I less than 2, I plus plus. So here it is number of rows for j equal to 0. So we have here number of columns 3. So we are writing 3, j plus plus. And after this we'll write printf %d. We can use /n and m3 ij, then bracket close, and then the loop has been closed, and now close the main program. So this is the whole program for matrix addition. So see here I have written this program for addition of two matrices, and where matrices here are two-dimensional. So just now I have discussed how to do it. So if here what I had taken rows and column, I have asked from the user what is the number of rows and number of columns you have in your matrix. So you can define it also, or you can ask it from the user. It is better to ask from the user. So just define the bigger size for the array. So here I have declared it is 50 by 50 matrix, X, Y, and Z. First two in the input matrices are X and Y, and the resultant matrix is stored in Z. And I and J is for iterating through the loop, rows and columns. For rows, I have taken this variable I, and for column, I have taken this variable J. So now, for this statement, printf and scanf, this one and this one. This is for taking the number of rows, and this is for number of columns. And then the first matrix input elements are entered from the user. For that, I have taken this number of for loop. See, this one for I equal to 0, I less than r, I plus plus, For j equal to 0, j less than column, j plus plus, scanner percent %d ampersand xij. So with this, we input the elements of for first array of first matrix, that is X, and similarly for second matrix Y, we take input from the user. So we can write something more informative also, so that which element we are inputting from the user. Like suppose the 0th index will be the first row and first column. Similarly, 0, 1 will be the first row and second column. So for that, just you have to increase the subscript or index value. To in the printf statement, you can write. Okay, so here see this two, after taking the input from the user in both the matrix X and Y, we are just simply adding two matrices using these two loops. For I equal to 0, I less than R plus plus I, and for j equal to 0, j less than column plus plus j, zij equal to xij plus yij. This is the main statement which add the elements of the two matrices. Okay, and after this, Zij will store the resultant of the addition of two matrices. And now we'll display it using this, again the same for loop, and we'll using this printf statement. Inside this for loop, we will just print the values stored at Zij, and we'll come back. So now run this program, build, compile current file. So this showing no error. Now run it. So suppose number of rows is 2, number of column is 3. We'll enter the elements of first matrix. Suppose the elements are 1, 2, 3. Next row is 4, 5, 6. The first element, first matrix is complete. Now suppose in the second matrix, first row is 2, 3, 5, and the second row is suppose 9, 4, and 2. So now the result of these two matrices, sum of two matrices are 3, 5, and 8, 13, 9, and 8. So it is correct. So in this way, you can do this program. Now we'll see how we can do the matrix multiplication in C programming. Okay. See, for matrix multiplication, you must know that the rule of matrix multiplication, that if two matrices are there, what is the order? Suppose it is M cross N, first matrix, and another matrix M2 is N cross P. The resultant matrix M3, the result in which we want to store the multiplication of M1 and M2, what will be the result, the order of this resultant matrix? It will be M cross P. Okay. And what the main thing is this N, the column, number of column in the first matrix should be equal to the number of rows of second matrix. So you can do this check also. Okay, you can do this check also in while writing program, that number of column of the first matrix is equal to the number of rows in the second matrix or not. If it is not, then you can write that matrix multiplication is not possible. Or for the time being, you can assume that it is satisfied. Okay, or you can take the same order also, like suppose 3 cross 3. This is also 3 cross 3. So resultant matrix will be also 3 cross 3. So you can assume like this also. But you should know this rule. If this is not equal to this, the matrix multiplication is not possible. So you can do this check. But now, what you have to think in writing the code for multiplication. So the taking the input is same as we have done for the addition or subtraction. You have same, like you have to take the same loop for ij. But when it comes for the multiplication of the two matrix, you need to take one more counter variable. Okay, you need to take one more counter variable k, which will help you to multiply through the or iterate through this way. Like suppose the first element of the first row, first column element will be multiplied with this. Then the second first row, second element will be multiplied with the second row, first column element, and this way it will go. So for this we need third variable to do this operation. Okay, so till now we have just used for taking input ij, for displaying also we need ij, but here we need one more variable k. Okay, to control this part, because we have to move like this. The first element of the first row is multiplied with the first row, first column. Then first row, second element is multiplied with the second row, first column element. And all this will be multiplied. After multiplying, all gets added. Okay, all gets added. That is why we need to take one extra variable. Yes, it's just to see here, for I equal to 0, I less than row I plus I, and for, let me write it, for j equal to 0, j less than column plus j. And then what we have to do, we have to initialize with the 0 the resultant matrix. So suppose our resultant matrix here is Zij. So we initialize with 0, all the elements with 0. And after that we start third loop for k equal to 0, k less than c, k plus. Okay. And then we write this part. The resultant matrix name is Z. So we write Zij. Zij is equal to, or you can write plus equal to. That is better, because this shorthand operator. So write plus equal to x and y. We have array name as x and y. So we'll write x I k into y k j. Okay. So this is the whole process. So let's see here on the system how we run this matrix multiplication program in C. So as we have done in the addition and subtraction, we will declare three variable matrices x, y, and z, and we have taken the large size 50, 50, 50 rows and 50 columns and 50 rows. And it is maximum size we are taking. Okay. So you can take the smaller values also, like 10 row, 10, 10, 10, 10, 10, 10. Okay. So for this, what we are doing, R and C are two variables we have taken to for rows and column. We'll ask it from the user while running the program that what is the number of rows and columns. You can fix also, but it is always advisable or it is always better to take the input of rows, number of rows and columns from the user. Okay, and after that, after taking the rows and columns, then we will take the another loop. We'll take a loop to take the input values of first matrix, and similarly for the second matrix. First matrix is x and the second matrix is y. So the elements will be entered using xyj, and for xij, and this for matrix y, we are taking yij. And after that, the third main part, that is multiplication of the matrix. So we want to store the result in the zij. Okay. So that zij is initialized with 0 here, and for I equal to 0, I less than row, I plus plus, and for j equal to 0, j less than column, j plus plus. And then we have written zij is equal to 0, means we are initializing here the zij all elements value with 0. And after that, the third variable counter, we have taken k to control the multiplication of both the matrices. For k equal to 0, k less than c, k plus plus, so that it will move. See, it is just here showing that this is controlling the multiplication part, that is this one is multiplied with this one, and the second second element of the first row will be multiplied with the second row's first column, means all these elements will be multiplied with the first row element. Okay, that is why it is said that number of columns here, the number of columns here should be equal to the number of rows here. Okay, so this should be multiplied by this should be multiplied by this, and this should be multiplied by this. And after multiplying this, once all the elements corresponding multiplication will be added, and the resultant addition will be stored in the third matrix first position. And this process goes on till all the elements are obtained. Okay, so this is the whole process. Let's run it. So let's run it first. So first compile. Return 0. Okay. Here I have written return 0, so no need of this statement. Since I am writing data and type is void, so again compile, no error, 0 error. So now run it. Number of rows, suppose number of rows is 2 and number of column is 2. the first matrix, suppose I have taken 1, 2, 1, 3. It is 13 now. Okay, no problem. Fourth element is 1. So the four elements, first 1, 2, 13, 1 of the first matrix, and that for the second matrix also I am taking the same rows and columns. You can take different rows and columns for the first and second matrix. Okay. Here I am taking, assuming that both are square matrix and both have same rows and columns. So just 2, 3, 4, 5. And now the addition multiplication of the two matrix is 10, 13, 30, 44. Okay.